math
Well,
never exists.
the only thing about that is the fact that
yeah, this is based on brain. Well, your brain is based on physics, which is based on math. So therefore, physics. I'm sorry. What physics is not based on math? It's based on biology. Neurology.
physics is not based on biology.
Physics is based on math. No, our brains are based off of biology. Yeah,
which is based upon chemistry. Biology comes from chemistry. Chemistry comes from math or physics, one of the two, and all. It all comes back to math.
Why does everybody steal my stuff? Because you can't do it. So I have to solve it for you.
The spaceship. Oh, I missed it! Oh no, no! I missed it. I was in a meeting. Oh, curse the world! But I wanted to watch it live. Now I don't even know if it exploded.
Did it explode?
I don't know. There is smoke. Let's see. All right, let me share this with Ben so he knows what I'm talking about.
What are you doing?
All right, I got to close my eyes.
All right.
All right, we're going back in time.
I'll watch it for you.
No, we're good. Why is that on that?
Why did you close your eyes? What are you doing?
Force officer who was responsible for having the flight termination system on a pair of switches, and basically he waits anxiously for the first 2 minutes, and if a spaceship. He said, what was yours? Rocky Road. That's rehearsal where.
How long was this going on for?
You have a crystal ball, so to speak. So,
no,
yeah, the vehicle we
got to get the rapid chill.
They've been sitting idle for a bit here. Anything that SpaceX has to worry about?
Okay, rapid chill. It's 10 minutes after siren or 5 minutes after siren. Ben, can you see this?
We don't need to do math. I can read ahead. I still think math isn't.
Hello, everybody. We're back for a brief intro and special introduction to another guest. We have with us again another guest here today. Answers with Joe. Joe Scott, hello.
Another guest? I thought I was special.
You are.
I am special.
The last time they did it, it crashed. It was spectacularly so.
Spectacularly.
The engine didn't relight properly and it crashed. Oh, that's means so. Oh, there it goes. Adjust the camera, damn you. Ah. That better not be the whole darn video. That's not much of a video.
Wow, that's intense.
Pan the camera. Oh, disappointing. Now you pan? You're a little bit too late. All right. The cameraman gets fired. You're fired. What did Trump say? You're fired? Is that what it is? You're fired. We're not even going to get to see it, whether it crashes or lands. Darn it. There's got to be better. All right. We will investigate this at the end of class.
All right.
Now we got to do the class, and then we'll investigate whether it crashes or survives. Last time it crashed, it was a big thing. I don't think it crashed because otherwise we would see it. Maybe it crashed into the ocean, though. All right. Any questions on the homework?
I think I get it.
I was on it. You get it?
Yes, I think.
That's pretty good.
But I don't want to answer because I'm probably not smart.
Ben, can you hear me?
Yeah, I can hear you.
We're just checking after yesterday's
stop.
snafu.
Do not do that. I'm not even joking.
All right, questions? Nothing?
No.
All right, here we go. Number 1 is 85 degrees. Number 2 is 80 degrees. Number 3 is 150 degrees. Number 4 is 50 degrees. Number 5 is 52 degrees. Number 6 is 55 degrees. Number 7, I think we did this in class, 30 degrees. I did not read number 8 last year when I assigned this, and then the period 2 brought this up and like, they didn't understand what it meant.
There's an infinite amount of possibilities.
That's what I said too. And when I looked at the answer in the book and then I understood what they were saying, it's just poorly written. So if the big hand is on the 12, then how many places could the little hand be if it's 120 degrees?
Oh.
2, and it's 4 and 8, but it's a poorly worded because it doesn't say anything about where the hands are.
Well, it says o'clock, so the other one would have to be at 12 for it to be.
Yeah, I also got 4 and 8, so I made that connection.
Okay, so Mr. C can't read very well. Neither can period 2, but you guys figured it out. I didn't figure it out. That makes sense. Okay. Number 9 is a picture for A and B. You find out that it does not contradict postulate 16.
Because it's a minor arc AC, not a major arc ABC.
Then we come to 10 and 11, and we kind of explained it all during class yesterday. A couple people in period 2 figured out there's a pattern in the table.
What a surprise. So did I.
Now, the question is, why is that pattern? And if you can remember this pattern, it's the proof for later on when we get to something that deals with this particular shape. All right, I'm going to call it left to right, top to bottom. So that first column would be 60-30, then 70-35, then 56-28, then 50-50, and then 2x. That's number 10. Number 11, left to right, top to bottom, 100, 50, 88, 80, or 44, 34, 50, 44, 104, and then P plus Q, and then a half P plus a half Q, and that was it. Number 14 was a proof. Hopefully you saw that there were some isosceles triangles going on there, and you took it from there. All right.
Yes, I did not know that we had to do 14, but I could solve it.
And it gives you the hint. It says draw O, Y. Okay, that was it.
Oh, yeah.
And I need my clicker. Ben, you questions on the homework?
No.
Good. All right. Today's a whole bunch of proofs. 3 of them, in fact. We're going to review everything we've done so far tomorrow, and then we'll take the quiz, and Thursday, new stuff. But nothing new tomorrow.
Nothing new on the
Just a review of everything. 9-1 was just vocabulary. 9-2 had one little tiny piece of information. And then what we did yesterday for 9-3. And then today we get some new stuff. We get 3 things. We don't get any formulas, but we do get skills, I guess you want to say, that apply to the 3 theorems that we'll do. They're all pretty easy. Once you see how the first one is proven, the other ones are proven basically the same way. Don't look in the book, Jack. You're going to spoil it.
Look at the homework.
Stop spoiling, spoiler.
I don't spoil things. I just look
All right.
smart.
We okay? All right, so arcs and chords. We dealt with arcs yesterday. Chords was that first day. Remember, we described what a chord was. So quick review. McKinley, you're up first. Tell me anything that you see in that picture right there, geometry speaking.
I can tell you an infinite amount of things in that picture.
Agreed, but I want one thing geometry about that picture. I see, fill in the blank.
I see a vector right thing.
A what?
A vector.
No vectors
I
there.
don't know what it's called, but it's
Vector, we'll talk about it in pre-calculus, but not.
it's an arc. That's
What do you see arc? Which arc do you see?
RS.
Is that a major or minor arc? That's a minor arc, RS. What do you see, Jack? One thing.
I see
That's not minor arc, RS.
major arc RTS.
Major arc, RTS. What do you see?
Chord R.
Chord RS. What do you see? Anything left?
All the metal sensors.
All the what?
The metal sensors.
What does that got to do with anything? It does.
Oh, that it can connect to.
Well, it's not connected. What's that? Why is that important?
Because that's a label for something.
Yeah, so circle O, right? And I guess you could also say we have points, TR and S and O, right? So these are all the things I came up with
There's more than just.
Well, we're just saying of what's depicted, not what
But you
could
can
be.
also say major arc TRS, and you can also say major.
We don't know if TRS is a major arc. Maybe it is. I don't think it is, but it could be.
Well, you could say fine, then you can say TS is a minor arc.
Yeah.
I mean, there's a lot more.
Well, not a lot more, but maybe that one extra thing. Okay. Reviewing definitions. Remember, if you have this construction, you have made a central angle, and the relationship between a central angle and the chord is they're equal to each other. Okay. So central angle and the chord that it creates are equal, the minor chord, right? We call that the measure of the arc. We're going to have later on in the chapter something called arc length, and that's when we actually calculate how much distance is there from Y to Z if we stay on the circle. So arc length and arc measure are really close to each other. And if I ask you on the test, what's the measure of the arc or what's the arc length, and you flip-flop those around, and you get completely the wrong answer. All right, the rest of the chapter is, there's lots of stuff to remember. Today is not maybe this bad, but tomorrow, I'm sorry, the next, not tomorrow because tomorrow's review, but on Thursday and Friday, it's a lot of stuff. All right, so we're going to start off doing a proof. McKinley, what do I got here? All right, sorry, I left off. No, yeah, it's McKinley's turn. What?
TU is an arc, and RS is an arc. There's congruent.
Okay, so I have two arcs, and their arcs we're told are congruent,
Yes,
and we're asked to prove
RS is congruent.
what is RS and TU.
RS and TU are medium.
No,
Medium, they're chords.
they're chords that connect what on this particular circle.
They connect both the arcs.
So the endpoints of both arcs that are congruent,
Yeah.
we connect them with chords. You see the construction? And somehow we're supposed to prove that if you have congruent arcs, then the chords that connect those two endpoints are congruent as well too. Okay. This is going to be a biconditional one. We're only going to prove it one way. Our book is kind of cheesy on that, but this will be a biconditional as well too. Okay. So there is the start. If Jack looked at the proof that's in the book, he's already spoiled it. But for the rest of you,
Oh, yes.
any ideas? Do we have any central angles? No. So let's make some central angles. So what do you want me to make? Okay. Okay. And by the way, if you make that, you're actually making radii. So it looks like this. Now, doesn't that give you, and I labeled angle 1 and angle 2, doesn't that give you the impression that 1 and 2 are vertical? Now, I want you to remember that, look up here, is that just because they put them right here, I equally could have said this, if this could have been my picture, right? I could have said this, and then it's a bit more clear that they're not vertical angles, right? Okay. So I wish they had drawn it this way, but that's from the book. Because I will have so many kids just say, oh, well, 1's congruent to 2. All right, you're in high school. How do all proofs go in high school?
2 column proof.
No. Yes, but no.
CPCTC.
Okay, so, yeah, but why are we going to use CPCTC?
Because you have 2 triangles.
I got 2 triangles.
And
So show the 2 triangles are congruent,
All right,
and then we can call it CPCTC.
all of those 4 that you just.
All right, let me catch up with you. Construction. Now what?
All of them are congruent.
Why?
All of the sides, because they're all radii.
They're all radii, so they got to be congruent. Okay, so now if I mark, oh, this is already dead. If we mark what we have, congruent, 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 looks like we could, if they were vertical, we'd be done.
No, but they are
SAS.
congruent. They are congruent.
Why are they congruent?
Because it's opposite the arcs. Opposite the arcs.
What is that from? And I couldn't remember, I had to write it out.
The Theorem 9.1.
I was actually pointing out that it's not Theorem 9.1.
Theorem 9.2.
I was pointing out it's not Theorem 9.2.
Theorem 9.3.
I don't think we've had 9.3 yet.
Postulate 16. I don't know.
Read postulate 16.
It's Theorem 9.3.
The measure of an arc formed by 2 adjacent arcs is the
Okay, so it isn't postulate 16. I need to change. I agreed with someone in period 2 that it was postulate 16. It's not. It's theorem.
9-3.
Is it 9-3, 9-3?
In the same circle or in congruent circles, two arcs are congruent if and only if their central angle.
And since it's biconditional, so it is 9-3. So that's 9-3. So we got 1 is congruent to 2 by theorem 9-3.
So then we find it.
So therefore by SAS. And therefore we can call CPCTC and we're done. Cool. Excellent. By the way, what was it we started with?
Two chords connecting the endpoints
Of 2 congruent arcs. This will be biconditional. I don't know why they don't write it with an if and only if. We could have handled it. They gave us the last one as an if and only if, but this one they didn't. So we get these 2 statements. If the chords of the same circle or congruent circles are congruent, then the arcs that are arcs that are created by those 2 chords are congruent. And then the converse of that is in a circle, if the arcs are congruent, then the chords connecting to the 2 endpoints are congruent. Either way works. McKinley, give me an acute angle.
OT.
Give me an acute angle, just numbers.
9.
What?
20. 20.
20. Clearly that's not 20. Here's how it works, and here's the skill you get from that. If that's 20, and this is 10 centimeters, and this is 10 centimeters, what's the measure of arc RS? And this should be degrees.
All right. 20.
Okay, it's not very challenging. So if I put 20 right here, degrees, and I erase that 10, if arc TU is 20 degrees and arc RS is 20 degrees, how long is chord RS? Okay, that's all it basically says. And that's how you will use that tonight in homework. So that's 1 of 3. 1 of 3 today. Yes, we got this one? Ben, questions?
No.
Okay. All right. For those that haven't looked ahead, take a look at the picture and tell me what definition I'm about to give you. So for those who haven't read ahead, take a look at the picture and tell me what definition I'm going to give you. What's it look like, McKinley?
It looks like a point to the middle of the arc.
So guess what we're going to call it?
Point in the middle of the arc.
Flip the words around. Yeah, there you go. See? That wasn't too hard. And it's exactly the way. Now they add one little piece to it. They say any line or segment that goes through Y would be called a bisector of the arc. So there's 2 statements there. One is the obvious.
We're about to get something very useful in the next year.
Because of this?
Partly.
No. I mean, this is just, okay, remember chapter 1, we had segments, then we had segment addition postulate, and then we had midpoint. And we did the same thing with angle addition, and then we had angle bisector, and now we have the same thing with arcs. Arc addition, and now we have arc midpoint. But yes, we'll do a proof next. We'll get something else, but and it does have something to do with a midpoint, but it has some other stuff going on. Now notice I labeled my arc as a major arc here, X, Y, Z. I gave it 3 letters. Generally, you're only going to give a minor arc 2 letters, but I don't think you're going to be lost on that. Now, it could be a major, it could be a minor. I just chose to put 3 letters in there. All right, we okay with that? Okay, not approved. Look at the picture. This is more important. Look at the picture. Tell me what you see. Don't worry about what we're trying to prove. Tell me what you see. What do you see, Alan? Outside and inside. Like in the military, we were always taught that when you're scanning for something, you don't immediately look for a little tiny thing. You look broadly and then you kind of focus in. So what do you see broadly? I see a circle. Okay. Now what else? I see a diameter. And I see a chord. What's so special about the diameter of the chord? They're perpendicular. That's the construction. When you see this construction, then you get to say something about it. By the way, read the proof and tell me what you can say if you have a diameter. Now, by the way, if you have a diameter, you also have a. So this is, although they show you a diameter, it could be a radius. So McKinley, if you see this construction, I have a diameter or radius, and I have a chord that's perpendicular to that diameter radius. What do you get to say? What parts of those? So in other words, if they're congruent, then Z is the midpoint of that segment. What else do we get to say, comma? Therefore, is the, on the previous slide, then D is of the arc. You see that? Oh, by the way, we got to prove this, but that's what we're doing. So you have this construction, basically your eyeball, I got a circle, hey, I got a radii or diameter, and it goes through a chord, and they're perpendicular. Now notice that doesn't always happen. Circle, diameter, chord, right? It doesn't have to go and be perpendicular, okay? And if that's the case, then it isn't a bisector of either the chord or the segment. Okay. Start, you've already seen how the proof starts. We make radii, right? So let's make some radii. Where are we going to go? Okay. Notice I labeled angle 1, angle 2. High school level proof, show that two triangles are congruent, call up CPCTC. Yeah, what are we going to say next?
That DZ or OZ is congruent to itself.
Reflexive, okay. OZ, I'm not sure if I did that. Did I do that? Nope. So OZ, I got it. Yep. What else?
The angle AZO and BZO are congruent.
They're right angles, right? Because that's definition perpendicular. There's my OZ. What do we got left to do? Jack, can we say the two triangles are congruent from what I've said so far?
No,
Why not?
because you have to say if the radiuses are congruent.
So what do you want me to say?
OA is congruent to OB.
Okay, because they're radii.
Yeah, radii.
So we got an HL.
Technically, don't you have to start from the midpoint or the center of the circle
For
for labeling radii? You go OB and OA.
you're correct. I labeled them wrong. However, there's nothing wrong with the way I named them. Now, if I want to specifically say radii all by itself, you are right.
Oh,
But I'm not necessarily, okay, yeah, probably I should be better to call it OA. But segment AO is still congruent to segment BO by the way I named them. All right, are we there? Hypotenuse leg? Yeah, so hypotenuse leg. And so therefore, what can you immediately claim? For what? But can I claim that for AD and BD? No. Okay, so we're halfway there. We just got through CPCTC, AZ, BZ. Great. How are we going to get the arcs? Hint, hint. Why did I label angle 1 and angle 2? I haven't used them yet.
Oh, because you can claim CPCTC.
Because I can also claim 1 and 2 CPCTC, and 1 and 2 if they are congruent, therefore, by Theorem 9.3. Okay.
Right, yeah.
There we go. Done. I forgot what the picture looked like at the start. What's the picture?
It's a chord or a
Diameter radius and a chord that are perpendicular. So that's the construction you have to have. Now, like I said, it could also be a radius and it'd still be the same thing. All right. So that's theorem 9.5. It is not biconditional. It's just a straight up statement. I suppose it could be biconditional if we proved it, but they just give it to us in one direction.
Because you never use the other side of it.
Well, what would it get? Well, yeah, because then you could claim that they are perpendicular. So if AZ, BZ, and the two chords or the two arcs are congruent, that just seems like a whole lot to do, right? I would have to show that this is congruent to this is congruent to this. And if that's true, then I can claim that they're perpendicular. No, maybe that's useful. By the way, I think it would be pretty easily done. Let's see. So if that's congruent to that, that's congruent to that. This is, I don't put arcs. I can make radii. And I have SSS.
Right, yeah.
Now,
Now
that was pretty simple. So it is biconditional. They just chose not to.
Yeah, since it's an isosceles triangle, then, well.
No, we're done because all we had to do was show that they're perpendicular.
Yeah,
The other
we
one.
didn't show that they're perpendicular. We showed that the two triangles are congruent.
I did. SSS.
Yeah, but we only showed that the two triangles are congruent. We never said that they're perpendicular.
Well, CPCTC,
Yeah, but
two angles that are on a linear pair.
Oh, true.
Okay, good on this one, McKinley? All right, so this is what homework would look like. They would say something like, gosh, I don't know. They might say that this is 20 degrees and this is 5 centimeters. Look at the board. So if AZ is 5 centimeters, how long is AB?
5 centimeters. No, 10 centimeters.
How? What is the measure of arc DB?
20.
What's the measure of arc AB?
40 degrees.
So that one's not too bad either, right? Okay, so two that aren't too bad, right? And if we were to stop right there, probably I wouldn't even lose period 2 kids. But we get this other one and this kind of piles on. All right, so this kind of like homework. A lot of stuff going on.
5 equals.
By the way, this is going to combine multiple things at once. All right, what do you got?
5 to x equals 5.
How are you getting that?
Because a
Unknown point.
unknown point is congruent to b in the number.
Well, why are they congruent?
Because of a theorem that we just went over.
Yeah, but instead of remembering the number, tell me what's the construction that gives us that.
Oh, if we make a triangle.
No, I don't mean that part. I meant like, what do you physically have to have in order to say that x is 5? You gotta have 3 things, sorry. I have to have what's the picture?
Oh, a circle.
Okay, I didn't include that. That's
You
4
have to have
things.
a diameter.
Gotta have a diameter or a radius,
Yeah, you have to have a chord.
a chord, and the two are
congruent, parallel, perpendicular.
perpendicular. That's what you gotta have. If that's the case, then yeah, that piece is the same as this piece. Okay, so x is 5. Now what?
And then y is just 86 divided by 2.
Well, where'd you get that from?
Logically makes
I
sense.
know, that's teacher thing. Where did you get that from?
Well, a an unknown point and b in another point equal.
You could have said AB.
AB is equal to 10.
And
F is equal to 10.
therefore, by theorem,
Yeah, some theorem, then 86 is, that means EF, rho, vector, whatever, arc EF is congruent to arc AB.
okay. And since EF was 86,
Then it, BD must be half of that.
BA must be 86.
Yeah.
Now, where are you getting the half from?
Because BD does not go all the way around.
No.
A.
I mean, you're 100% right in what you said. You just haven't proven me why it's right.
Because
Why is Y half of 86?
Because it's not where B should be.
Oh, that's not really why. Why?
Because I say so.
Because of the last theorem. What's the last theorem say?
The diameter that is perpendicular to its chord bisects chord
And its arc. That's why. Now you had it right from the start. I'm just saying you got to be able to by the way, here's everything that you finally said in written form. By theorem 9.5, therefore x is 5. Therefore, AB is 10, and this is 10, right? Therefore, by 9.4, if that's 86, then AB is 96, and therefore by 9.5, it's half of it, 43. Okay. Sometimes they may just have you words. All right, you ready to catch? Yeah? All right, draw the picture. Sorry, Ben, you can't see this. She's going to try to draw the picture of what the words say.
Sad.
Oh, she's trying to draw a picture of those words.
How do I make it say that all this is fake? Not just the.
Yeah, maybe draw another line. That's 8 or 5. What is it? Yeah, 8. Put a dot in the center.
Here.
No, a dot in the center. So that therefore that has a radius of 8, right?
Mm-hmm.
Okay.
That one.
Yeah, that's clear. Okay. You guys agree?
Yeah.
Yes. Wait, but I have a question. On your picture that you put on the sheet, it shows that it's perpendicular, but it doesn't actually say that.
It doesn't actually say it's perpendicular. I noticed that as well too. So somewhere in there it needs to say perpendicular. Otherwise, this isn't necessarily true. Could be true, but it's not necessarily true. So we're going to assume that it's perpendicular. Otherwise, this doesn't work. Okay, looks like a good picture to me. That's not how I chose to draw it, but that's one way of doing it. Okay, go ahead and erase that. I'll actually leave it up there. Well, got in the way. So that's how they chose to draw it. Now, they just left off the fact that the radius is 8. Now, your picture was fine, but guess where they're going to put the 8?
As a
Because we're trying to figure out what? We're trying to figure out how long the chord is, right? So instead of making the 8 go from here to here, they're just going to make a triangle. You see that?
All right, can't you just use a partner's leg or something?
Now, what are we trying to find out? We're trying to find
AB.
We're trying to find AB, the distance of AB. Okay, what do you think?
Well, I would say 8 plus 8, but the chord isn't exactly big.
Is AP 8?
No, AB is, oh wait, maybe? I know there's some way to prove that.
It's AP, what is AP is, yes, it's 8.
It is not 8.
Oh, well, if it was right, if AOB was right, then it would be 8. You can find it out by using the, what is it, is it AB?
Nope, that's what we're trying to find out.
We're trying to find out what AB is?
Yeah.
And
This is what we got so far.
Wait, can't you just do, so I'm noticing on this picture there's an X where A is.
Yeah. Okay, so if we knew what AP is, then we would just what? Double it to find?
so you can just use Pythagorean theorem.
Yeah, I'm thinking of Pythagorean theorem.
Yeah?
Yeah.
Okay.
So 5
Let's use Pythagorean theorem. So-
64 equals 25 plus x.
So what's 64 minus 25?
number.
Or 39.
Okay, and then we got to take the square root. So how long is AP? Don't overthink this.
The square root of 39.
Okay, so how long is AB?
2 times the square root of 39.
There you go. Okay, tonight for homework, the Pythagorean theorem will sneak up on you.
They will.
Because you're gonna get a construction,
I've been doing something horribly wrong.
and I'm not saying for every problem, but for some of them,
I've been
you
doing-
might want to have to throw the Pythagorean theorem in there. If you got a right triangle,
I'm already done, then I've done nothing.
I thought there was at least one of them that had a Pythagorean theorem.
Let me look. All right.
All right.
Another way to do it without it.
We'll, and that could be possible as well too. We okay on this?
Yes.
All right, last one. All right, once again, the key here is to look at the construction. What's the difference between this one and the previous one? McKinley,
Yeah.
Jack, look at the picture. What's the difference between this and the previous one?
It's the
You got two of
radii
them.
are bended.
Got two of them. Now, what's the given?
Uh,
What's the given?
Circle O and that OQ is congruent to OQ.
So this is also part of the picture, is that this is congruent to that. So that's part of the construction. So when you call theorem, whatever this is going to be, 9.6? 9.6, okay. When you call this out, that's what you got to have in your mind. 9.5 deals with that picture, except without the tick mark, right? Here's 9.6. Okay. All right, you're on. Somebody. What do you think?
Well, you know that R and RP and PS are congruent
Why do you know that?
because the chord and the
Because of
radius are
9.
perpendicular.
Okay.
And then you can say the
Same or
thing
different?
about TQ.
Same or different?
TQ and Q.
Same or different than this one?
Same.
How do you know? And that's the issue. We don't know. So, not that that's false, that is true. Let's hold off on that one. It is true, by the way. It's true that this is congruent to this, and this is congruent to this, but we just can't say that this piece is congruent to this one. We don't know yet. Certainly, these two are congruent, but are they congruent to each other? Not from the picture so far. How do we do the other two proofs?
CPC.
Okay, so what do you want me to do?
Draw a line. Draw radius OU.
Okay, continue.
And then
Oh, that's
then you have
How about continue that thought? Not just OUOS.
and then also RU OT.
Okay, yeah, let's do all four of those. Okay.
Okay.
Since they're all radii, therefore,
Congruent.
and what kind of triangles do we have?
Right triangles.
Therefore,
They're all congruent.
they're all congruent. They're all congruent by
HL.
HL again. Now we proved what your initial thought was, is that these pieces are congruent to that pieces. Okay, big picture. If this is 2, this is 2, this is 2, this is 2,
Both of them are 4.
they're both 4, right? So this is the logic of what I'm about to say right here, is that the whole darn thing is made segment addition postulate, right? But they're all equal to exactly the same number. TQ, UQ, RP, and SP are all equal to the same thing. Therefore, it doesn't matter. I'm adding them together. I'm going to get the same number. Therefore, TU must equal or be congruent to RS. QED. Yep. By the way, what did we just prove?
Theorem 9.6.
What is the picture?
If
What?
if 2 points if two chords midpoint are perpendicular to a radius that are both equidistant from the center of the circle, then 2 chords are congruent.
And you can leave off the midpoint. It's not. It's just what do you call the appendix? It's
Useful.
what's the word?
It's useless.
It's not needed extra. What's a word for it? $20 word. What's the $20 word for it?
Appendices.
Superfluous. Is that it?
No, superfluous means like really good. Let's see.
Hey Siri, what's superfluous? Unnecessary, or excessive. There you go. Yeah, I was right. You're wrong. +1 for Mr. C. Okay.
You get a +1 for Brown.
Okay, write this down. This one is biconditional. So if now it could be diameters, right? But we're not talking about the diameter portions. We're not even talking about the radii. We're talking about the segment that comes off the center that's perpendicular to a chord. And you got two of these chords. And if that piece is congruent to the other piece, then the two chords are congruent. And then we have the other way we could say that. If you have two chords that are congruent, and there's a line that's going from them to the center, then that's congruent. Cool? All right. Here we go. Last one. McKinley, you're up.
Okay.
I only got one variable x.
So, yeah, 4.
You're just going to throw out 4? You got to prove it to me now.
I have to prove it now, but okay. Theorem 9-6.
No.
There. Now
Use
there's-
words and tell me how why it is 4, by the way.
Well,
Why?
Because
What was the previous theorem? What was the name of it?
Theorem 9-6.
It's not 9-6. Why this is true, by the way.
It is 9-6.
Hold on. To get started, it ain't 9-6.
We go back to 9-5.
What did 9-5 say?
The diameter that is perpendicular to the chord bisects the chord and its arc.
So use that on that picture. Tell me something.
X equals 4.
No,
Yeah.
that's not what it says. That's not what 9-5 says.
9-5 says x equals 4.
Does not say that.
But it leads to that.
9-6 says that. But 9-5 says something we got to use for this.
9-5 says that the chords bisect each other.
Okay, so use that on that picture.
So RT and UV bisect each other. That's not
RT and
UV.
how about QS?
Oh, QS.
And it doesn't they bisect each other. It's that QS bisects RT.
But it also bisects.
No, QS only bisects this chord, doesn't bisect that.
Oh, well then Q and another number share the same radii length.
There's no radius up here, by the way. There's no diameter up there.
But there's
9-5 says if you have, I'm going to cover everything up but that. If you have that construction, what? If you have this construction, what? What does 9-5 say?
bisects.
Bisects what?
QS bisects RT.
So therefore you can say,
That they bisect each other.
what does that mean?
That
What does it mean? According to this picture.
3 plus
Now you're getting hotter.
3 equals 6.
No.
Length of
Oh, okay.
RT.
That statement's just incorrect. 3 does not equal 6.
But I think what he was trying to say is, if this piece is 3,
The other piece is 3.
therefore the whole thing is,
3.
why is, what?
3.
Again,
No.
You're saying that 3 equals 6.
So
Stop doing
why is that important?
Because on the other side it equals 6.
Because on the other side, now we're able to use 9-6. Is that right? 9-6.
Which means I was right from the
Agreed. I never argued with that, but you never proved it, right? So if this is 6 and this is 6, therefore these are congruent,
Yeah.
right? Because of the perpendicular nature. Remember, we measure distance perpendicularly. Therefore, if that's 4, that's 4. Now you've proven it. Ben, did you track all that? Oh, by the way, here's in words what
Yes, I
McKinley's-
did.
All right. I think that was it. I don't think there was anything else I wanted to show you. Here's a big long proof. By the way, we did 9-6 in class. And ours is much prettier than theirs. Okay, that's it. Any questions?
No, not for me.
18. Let's take a look at number 18.
I did it and I didn't even know that. Well, I did it right, but I mean, I gotta draw a bunch of stuff.
Is it a proof?
No.
So you have a circle.
I
you
got
have
it.
diameter.
Are you sure you got it? I am 100% sure I got it.
You got HG. And then you got a chord down here at the bottom. And that's DFE, and it's 9 degrees. D, F, and E's right here. Okay. What are we trying to prove?
That
If OE, and circle O, if OE, right there, I'm going to draw an arrow. If OE is 8√3,
what is HG?
so we're not doing a proof. We just got to figure out where HG is.
All right.
So HG is the diameter. Okay. So this piece right here is that.
You also know that HF equals 150. You have to have that.
And from here all the way to here is 150. Okay. Which means this piece is
30.
Not sure if that helps.
It does. Now you can draw OF.
Hold on, get everybody. You gotta digest. All right. Clearly, OE is not the whole radius. We would just have to double if that was the case. We got to figure out what this little tiny piece is right here, and then we got the whole thing, and then we can double.
You don't actually have to figure out what these tiny pieces.
Well, or then we got to figure out what HO is. One of the two.
Or
Well, the goal here is to figure out what the.
I figured out what OF was.
It's a radius and double that. Okay, I'll go with that as well too. Either one. So, right triangle.
And GOF equals 30.
We got one side. We got to have what, two?
No, you
Two Pythagorean theorem.
You just gotta have one.
We know that cuts that in half. Okay.
You can just say that GOF equals 30 and then just do cosine.
Yeah. Okay.
I couldn't figure that out though. I would figure out how to draw a whole.
So we have a triangle that stands this way. He's claiming that this is 30. Why? Central angle, arc, measure 30. The side opposite 30 is A. The hypotenuse is
OF.
Hypotenuse is
C.
2A.
Yeah. Oh, well, yeah, okay, yeah, fine. I just did cosine.
And this side is A√3. So what's A?
8, and then 2A is
16.
Oh,
Boom! Beat you. Easier. You need a calculator.
I did, but it worked.
Yeah. There was a famous, not famous, but there was my geometry teacher. I remember we're doing something, and it was towards the end of the year, and she wanted me to do something like this. I mean, it is literally the same thing. And I was like, Miss Shanklin, give me a trick sheet, because we didn't have a calculator. We had the table. And I was like, give me the trick sheet. She's like, I want you to use special right triangles. And I said, well, your instructions just say find the answer. I could find the answer using sine, cosine, tangent. She was like, fine, take the darn table. So there's my Miss Shanklin moment to you. Fine, take the stupid table.
Ah,
All right.
I win.
Well, you did get to the right answer. True. All right, questions? All right, we're done.
I don't have any questions. All right.
The answer about 20 minutes before you did.
Whoa. We started
Goodbye,
it during
good-
class. All right, have a good day, Ben.
Goodbye. Have a nice day.